Well, good evening, everybody. Thank you for logging in tonight. My name's Eric Blair. I'm Vice President of the Leeds Philosophical and Literary Society, and we're hosting this in collaboration with the James Hutton Institute. And it's a great pleasure for both of our institutions to be collaborating on something that's very, very, very important at this time, and also look back to the founding spirit, James Hutton. So it's my great pleasure tonight to introduce our speaker, Colin Campbell, and to just tell you a little bit about Colin. He studied microbiology at Strathclyde, and he also did his PhD at Strathclyde on microbial decomposition of soil, and he's had a sort of an uninterrupted interest in soil microbiology, the sort of microbes that inhabit soil, and how soils can be protected for the future. After his PhD, he spent some time at Edinburgh University with the Hill Farming Research Organisation, and then moved to the Macaulay Institute of Land Use in Aberdeen, where he was there for a fair period of time before moving to the James Hutton Institute, where for the last 11 years he's been the Director and Chief Executive Officer. Colin has collaborated widely, in particular with groups at the Swedish University of Agricultural Sciences, where he's had a number of joint projects, again on soil science. And he has also advised the Scottish Government on protecting the nation's soils. So it's a great pleasure to have such an expert on soils, which was a big focus of James Hutton's work, and to hear about James Hutton and the institute that bears his name. So over to you, Colin.
Thank you, Eric, and thank you very much to the Society for the opportunity to speak to everybody today. Can I just check you can see a slide, the title slide?
Yes.
Yeah, great. Okay. So the sort of, thank you, lots of emojis coming up. That's good fun. So I want to talk about the legacy of James Hutton and the spirit of Enlightenment science in the 21st century. And you know, as we go through this, we want to celebrate 300 years since the birth of James Hutton. And but really also, how does the James Hutton Institute continue that legacy? And I hope to persuade you that we do continue that legacy to understand our living landscape and shape a more resilient future for us all. And the talk's going to be in three parts. I'm going to talk about James Hutton, who he was as a person, what was his lived experience and motivations, as well as his achievements and legacy. I'm going to take a bit of an interlude there and talk about some of the tercentenary celebrations and projects, because quite frankly, we've been overwhelmed by the way people have joined in with this tercentenary celebration this year, and I want to tell you a bit about that. And then in the third part, I'm going to talk about James Hutton Institute science and how we can take inspiration and wisdom from this period, and also what are the lessons from the Enlightenment for us today towards the end. So what about James Hutton, the person and his lived experience? So this is the famous Raeburn portrait of James Hutton, and in the Scottish National Portrait Gallery. And I don't know what you see when you look at this portrait, but I've annotated, which always irritates artists if you annotate artists' great works of art. But as a scientist, I like to annotate things. And what you see is a man with a bare head, no wig, tanned face of an outdoor person. He looks lean and fit. You can see the 2 volumes of manuscripts and letters on the table, indicating he was a prolific writer and scholar. And you can see the rock specimens, which were as readable to him as a book. And he's wearing this brown tweed raiment, probably of a farmer from the Scottish borders. This is a very humble photograph, I would argue. If you look at some of the other Scottish Enlightenment figures, they're bedecked in fine clothing, wearing wigs and looking very, very grand. Hutton really wasn't like that. He was a very humble, unassuming individual, and very much this outdoor person who travelled all over Scotland looking at rocks on the back of a horse. And he grew up with his mother. His father died when he was only 3 years old, and lived all of his life with his three sisters. He was unmarried. He fathered an illegitimate son who he supported all his life. But it appears like he suffered from unrequited love, and there was some sort of other barrier to marriage. And there's a lot we don't know about his personal life, and who the mother of his son was, for example. And one of our great desires from the tercentenary is that we discover something new about Hutton, and that people find some of the lost correspondence that described his life. But a bit like Robert Burns, he was a man of the people and was well known for his humour and good company. But what was Hutton's world like in the 18th century? I mean, Edinburgh was growing rapidly at this time, 57,000 people to almost 87,000 people by 1791. Life expectancy was very low, 35, 40 years. Infant mortality was really high. It wasn't a very clean city. You had to queue up for water. It was quite smelly with waste problems. Most households relied on coal, which is expensive for the poor, peat or wood, which was scarce. And the homes were cold, smoky, poorly ventilated. Rural Scotland was still largely agrarian, with most people in small villages and estates. Food shortages were common, and in bad harvest years, 1740s, 1770s saw a significant hardship. But despite all these hardships, and maybe because of them, helping to motivate, Edinburgh was this global centre of the Scottish Enlightenment. And this was a chronology of Hutton's life in the 18th century. Now, it's quite a busy slide, but it shows when he was born, when he died. His publications are in grey. But there's three very significant events in his life in yellow there. The Second Jacobite Rising when he was a young man, American independence, and the French Revolution. I'm not aware of any correspondence or words by Hutton about any of these major events. You almost get the impression he was solely devoted to his work and the pursuit of scholarly works, indeed, through that period of time. But the sequence in which he did all of his achievements is really important, because what we see is in his early years, undertaking problem-solving issues, pragmatic solutions to problems of his day around food, for example, food security in his agricultural work, but over time becoming much more academic and scholarly, particularly after the formation of the Royal Society of Edinburgh, and we start to see major theories being published and really much more serious philosophical works over time. So it's that sequence which is really important in terms of understanding how he developed as a scientist, a polymath, and a philosopher. And he travelled widely, like many of the figures of the Scottish Enlightenment. They were very well connected with the continent, particularly France, and the Netherlands had a major influence on many of them. Hutton himself finished his medical degree in Leiden, but he also travelled widely in England, into the Midlands as well, from Norfolk and into Wales, indeed. And this was not a situation where, as somebody who lived in Scotland, was isolated from the world. They were very connected and understood the international efforts and insights from other philosophers around these regions.
Yeah.
Obviously, in Edinburgh at this time, there were a great many luminaries, and Hutton was contemporary with a wide range of very significant individuals who were part of the Scottish Enlightenment, many of them as very close friends, such as Joseph Black and John Clark of Eldon. But you can see here again, it's a mixture of different types of Enlightenment figures, including artists and writers and poets, very pertinent to the Leeds Philosophical Society. This is the Edinburgh Literary Society, and the famous painting by Charles Martin Hardy of the meeting of Robert Burns and Walter Scott. And again, this is typical of the ways in which people interacted during the Scottish Enlightenment. At events like this, with mixed company, very mixed range of arts, humanities, scientists, medical people, and physicians, all meeting together to discuss the great matters of the day. It's a fascinating painting with many things going on in it. You can see here James Hutton with some of his colleagues is present in this. And this is often used also to talk about how Hutton and Burns possibly interacted. Both of them were farmers interested in farming. And indeed, the arts and the sciences influenced each other to a large extent. It's often claimed that one of Robert Burns's most famous poems, A Red, Red Rose, is inspired by geological knowledge, possibly and probably from James Hutton. To all the seas gang dry, my dear, and the rocks melt with the sun. The geological references here are very, very strong, and it's often assumed that this is the arts and the sciences interacting together. There's also evidence that from another of Burns's inscriptions, where Burns, after being asked about the presence of a large and a small woman, what did he think about it? He asked why God made the gem so small and why so huge the granite, because God meant mankind should set the higher value on it. And it was typical of Burns to sort of defend the common over the rare. And what's really significant about this was granite was hardly known about at that time, whereas on the other hand, Hutton was utterly obsessed with it. In fact, he said, I've been particularly anxious about the subject of granite. So it's quite strong circumstantial evidence that Hutton and Burns in the arts and the sciences were collaborating during this time. But what about Hutton's actual contributions? Now, this is a long list, and apologies for that, but it is a long list of achievements. And it's quite often the order in which it's presented. People talk about his theory of the Earth, rewrote our understanding of Earth processes, the father of modern geology, and the start of Earth system science. Really consequential findings. Without this deep time, the theory of evolution doesn't work, intercontinental drift doesn't work, and indeed the Earth system science and the dynamic nature of it stimulated the Gaia theory by James Lovelock, so hugely important. Theory and principles of knowledge gets a bit of a mention sometimes, theory of rain a little bit, his agricultural experiments on lime, not a huge amount, but I'll give you some reasons why that is later on. But he also established the principle of natural selection and that the environment selects 80 years before Darwin's theory of evolution. And he was a co-founder of the Royal Society of Edinburgh, and did various other knowledge made useful type things like describing the difference between culm and coal to help with tax problems around coal and culm, and he surveyed the route of the Fourth Canal. And he was also a talented chemist who, with James Davy, established one of the first nitrogen factories in the UK, making sal ammoniac. The problem with this list is it's in the wrong order. It's not in the order in which he actually did things and how things developed. So I'm going to present it to you in a slightly different way now, because he had many identities. He was known as the good doctor, and I'm not sure that was because he was actually a good doctor, but he was very good company, and that was the context in which it was put. He was a farmer and a geologist and a polymath. And these developed over time in terms of his work. So his medical thesis, which was on blood as a circular system, influenced his approach to system thinking about the connections between components as part of a bigger system. He was fascinated by chemistry and the reaction of materials, which led to the sal ammoniac, which was hugely important in giving him some financial independence. And when he started farming, he experimented with lime as a fertilizer. While digging out ditches, he pondered soil formation, and that led to his enthusiastic interest in rocks and later the theory of the earth. And his farming led to an interest in climate, soil, crops, and even the physicality of his labours stimulated an interest in land economy and worker-employer relationships. All of this experience together will have informed his theory and principles of knowledge, in which he formalised the scientific hypothesis-led approach. So he was really developing over time from being a very pragmatic problem solver into quite an accomplished theoretician, academic and philosopher. And I find that one of the most remarkable things about Hutton and the way in which he progressed throughout his lifetime. Now, to give you an example of how rigorous he was about this in an application of systems thinking, I want to talk about something that you don't hear much about, and that is that James Hutton studied the Chinese language. Now, Hutton's interest in Chinese was philosophical, not linguistic. He believed that understanding how languages encoded ideas would help him to understand how humans form concepts, how reasoning develops, how error arises in human understanding, and how writing systems shape thought. His conclusions were quite surprising for a European thinker. Quite clearly, Chinese characters are not purely pictorial. He argued it was a system of conventional signs that encodes abstract ideas. And this all supported his broader philosophical argument that human thought is not limited by the form of writing, and that Chinese grammar and structure reveal universal features of human cognition, and showed and supported his theory of error. For example, he argued that misunderstandings about Chinese writing illustrated how humans project assumptions onto unfamiliar systems. Error arises from prejudice, analogy, and insufficient observation, and disciplined inquiry is needed to correct mistaken beliefs. So I think this is a really peculiar example demonstrating his peculiar logic and rigour around a systematic approach to studying almost any subject. And for me, this all underpins the principles of knowledge. And the principles of knowledge is one of his works which hardly gets a mention. Now, I have to admit, it's pretty turgid and difficult to read, but I think it was incredibly important in its time. These are some of the quotes from the principle of knowledge about observation being the basis of all philosophical inquiry, and to reason from a knowledge is often useful, but may mislead, and that we cannot be sure of the truth of our deductions without the constant application of experiment and the appeal to nature itself. And perhaps my favourite is that truth and error are forced to struggle together. It's almost rhythmical in that early first few words, but it's hugely important and very, very relevant today. And it's only in proportion as science removes the erroneous conceptions that truth can find itself in natural philosophy. So for me, Hutton's work was a body of work over a long period of time. Over time, it grew in importance, but it was all very dependent on the previous piece of work it's done. If I had a wish for the tercentenary, I would like to see a lot more scholarly study of the principles of knowledge and a much better translation of what it means for science today. So I'm going to switch to the second part of the talk here and just talk a little bit about the tercentenary celebrations, partly as a light interlude to the talk and to keep people's interest. So when we first realised that 2026 was the 300th anniversary, we got a few people together to talk about how we would go about celebrating it. And what we really want to do is celebrate the person, but his ideas and impact. What was quite apparent was that James Hutton wasn't that famous. If you ask the Royal Society of Edinburgh, you might say the top two scientists in Scotland are James Clerk Maxwell and James Hutton. If you ask the general public, James Hutton would be unlikely to get in the top 10. And what was striking was that James Hutton was probably more famous in the United States than he was in Scotland. This is some text that the special presidential envoy John Kerry gave when he came to visit in 2023 ahead of COP28. He talks about how it's appropriate to be here in Scotland, where less than 300 years ago, from Hutton to Hume, groundbreaking thinking contributed to the Enlightenment, not just of a country or continent, but of civilization itself. He goes on to talk about Hutton in particular, and in doing so, he may well have been the world's first climate scientist. And this really shows you that Hutton has great traction in the United States of America. And one of the things we learned in the many conversations we had with colleagues in the United States of America was that part of the reason for that is that the Scottish Enlightenment is taught in the US school curriculum. Now, as far as I've been able to ascertain, and apologies to anybody who knows better, it's not taught as a subject in Scottish schools, even though it's the epitome of the type of interdisciplinary thinking that the Curriculum of Excellence has at its core. It is available for history students in Scottish schools, but only as an option in later years, and they have a choice between studying the Scottish Enlightenment and the Nazis. I suspect quite a few study the Nazis. So we felt we had a challenge to raise the profile of James Hutton in 2026, and we established a website, and please do go to this website if you want to get any information about James Hutton and what's going to happen in this year of celebration. There's a countdown page, which is obviously very close given it's the birthday tomorrow, but you can join the mailing list and you can explore the calendar of events for the tercentenary year. I'm immensely grateful to all of the institutional and individual partners who are part of the tercentenary campaign group. You can see them here. Many of these organisations have leaned in very, very heavily to the tercentenary celebrations, and very grateful to all of them. One of the things that we were really overwhelmed with was the way in which the arts and creative community joined in the celebrations. And I want to just show you in a series of slides some of the artistic events that are on during 2026. And the first is the Earth Matters exhibit at the Royal Botanic Gardens, Edinburgh. Please, if you get a chance, go and see this exhibit. It's absolutely stunning. Over 20 works of art celebrating the ideas and concepts that James Hutton investigated. You can see the main picture there is depicting soil erosion, really stimulating to see, and you get the chance to see the lost drawings of Clark of Eldon and the original unpublished manuscript of the Elements of Agriculture. Royal Scottish Academy's 200th annual exhibition is also celebrating deep time. The convener's Annie Catterall. Please do go and see this if you get a chance. Tomorrow at the Royal Society of Edinburgh, we're trying to think like Hutton, shaping the next 300 years. And I'm afraid that event is actually sold out, but I'm going to give it a shout out anyway. And there's lots of other smaller exhibits all over Scotland, and I'm just going to pick on one of them from the Athol Estates, where Jake Harvey, Helen Douglas and Alan McCurdy have put on an exhibit at the Athol Estates, where Hutton visited and did his geological tour of Glen Tilt. And also there's a concert at Greyfriars, the Hutton 300 concert. You can still get tickets for this, so please do sign up for that. And you see there's a wide range of ways in which the arts and creative community are getting involved in the tercentenary for 2026. And the James Hutton Institute have also contributed, so you can now see a crop art portrait of James Hutton in a barley field if you're flying over Dundee. So do look out for that if you're coming in across Dundee. But we wanted to also have really significant legacy projects. And the one project that we really wanted to make sure we did was to open up a new deep time trail at Siccar Point. And these photographs show this new deep time trail, which opened just last Friday. I think the Scottish Geology Trust and the Edinburgh Geological Society have done an absolutely fantastic job of this. And it was a really successful day. And this is a true legacy of 2026 for everybody to enjoy the significance of the Siccar Point and Deep Time Trail. We also undertook the conservation of the lost drawings of John Clark, and these have been conserved and restored. And we've also now got digital copies of the lost drawings. And you can see here so many artists and scientists meeting at the Hunterian to discuss that lost drawings portfolio. And I'm very pleased to announce that in 2026, we will publish the unpublished manuscript of James Hutton called The Elements of Agriculture, edited by Alan Weretree, a full English transcript with commentary on what's new and different in the Elements of Agriculture. So I hope you see there are lots of new legacies from 2026 which elevate James Hutton and his work in 2026. We also have some celebratory bottles of whisky. There's one from the Isle of Arran malt in celebration of James Hutton. It's going to be called The Geologist, and I was very excited today to learn that the first one's arrived. So that's just arrived today, so I'm very pleased to see that. So do watch out for your chance to buy one of these limited edition malt whiskies celebrating James Hutton, the geologist. So what about the James Hutton Institute today, 300 years after his birth? What do we actually do? Well, we work in the context of the global challenges that are facing the world. I'm sure you've seen this type of graphic before, showing how our population has increased. We've got massive increase in demand for food, for energy, for water. All at the same time, we have no more land. And we have climate change, land degradation, and biodiversity loss. Very significant challenges. Now, I wouldn't want you to get the impression I'm saying this is due to population. We fully understand that it's the consumption per person that is the issue. And we are over-consuming our planet and we're wasting our resources. These are really serious challenges. It's reflective to think about that a lot of these issues actually started during the Enlightenment. Scotland played a leading role of developing the fossil fuel industry. We all played a role in the industrial and agricultural revolutions. And a lot of our issues around the extractive economies, the colonisation of other people's natural capital, they all started during this period of time. Now, that was a very different period of time where food wasn't plentiful, energy wasn't plentiful, water wasn't plentiful. And it's not a judgment on or blame to say these things, but it does put a moral responsibility on us to think about how do we lead ourselves through the next 300 years. And Scotland is still rich in natural resource. Our population's not growing. We still have food and societal inequalities, but they're poverty related. And we do have habitat degradation. We've lost very large amount of our native pine woodland, for example, in the last few hundreds of years. But we still have major opportunities. We still have abundant fresh water, high potential for renewable energy. And these are great opportunities to rethink how we're going to develop over the next few hundred years. And these are complex problems. They need many different disciplines. And at the James Hutton Institute, this is the diversity of science that we have available to us. Now, Hutton might have recognised some of these words, but many would be very new to him. We have a very unique mix of social and natural sciences because we understand that our problems often start with people and end with people. We need to understand people's behaviour. That's why we have environmental psychology, as well as studying the soils and the physics and the chemistry and the virology of our natural systems. This is really important to be able to tackle these complex problems with these multidisciplinary, interdisciplinary approaches. How do we do it? Well, we work at the landscape level, studying wildlife, natural regeneration and restoration. We work in the field, testing new crop varieties, disease control methods. We work at the farm scale, studying socioeconomic systems. We work in the labs, and we're very fortunate to have state-of-the-art facilities to conduct experiments and analyse the nature and composition of everything from DNA to natural products. We increasingly are working with communities. We use glasshouses for studying soil-plant microbial interactions, and we're increasingly using data science, including high-performance computing, to synthesize and analyze large data sets. So the type of way we do science has changed enormously since Hutton's day. We also work very internationally. There's virtually nothing we do that's not an international collaboration. And this map shows all the places in the world where we collaborate today. And science has become a very international discipline with major pieces of work having 20, 30 different institutions from around the world working together. We're also a national data centre, and we've characterised Scotland's land in many, many different ways. This is just some pictures from our James Hutton Institute Atlas, and all our data is freely available for those who want to understand Scotland's natural resources. We still also study many of the things that James Hutton studied. If you take, for example, rain, his theory of rain was written in 1784. Clearly, we need to understand the patterns of rainfall and how they change over time. And this graph shows the total amount of rainfall that lands on Scotland's land from the 1960s through to the 2020s. The amount of rain we get is absolutely enormous. 160 billion cubic metres of rain falls in Scotland annually in some years. That's 4 times the total amount of water that's held in all of Scottish lochs. And it's going up. With climate change, we're getting more rainfall, but also the amplitude of the dry and the wet years is also increasing. So we're potentially going to have twice as many drought years in the future than we currently do. So even though we've got all this abundant rainwater, we're still facing major challenges. Now, some people find it quite depressing to talk about this amount of rain, but as we say in Scotland, today's rain is tomorrow's whiskey. It's also our potatoes, our milk, and many, many other agricultural products. And we are very fortunate we have, by and large, rain-fed agricultural production, rain-fed tree production in our country. And that puts us at much greater comparative advantage to many parts of the world. Hutton also studied temperature, and this is an interesting example for me because Hutton essentially came up with the concept that crops need a certain amount of heat days to grow and reach maturity and yield fruit grain. So the number of accumulated temperature degree days is still used today by farmers for timing fertilizer applications, especially in grassland. However, there's a big disconnect between Hutton's original thinking and it being rediscovered by modern agronomists, possibly because the Elements of Agriculture was never published, and therefore there's a disconnect between what Hutton did originally, and he was one of the first to do this, and how we use it today. Similarly, Hutton was very interested in temperature, and this just shows some data from the James Hutton Institute's Invergowrie Met Station, again showing our temperature over time is increasing at different depths in the soil. And this has profound impacts for crop growth, for the decomposition of organic matter in soil. And this is not something that he would have been aware of, that these trends were likely to start in his time and continue to this day. And that has big implications for how we use our land as well. And Hutton studied land, and again, this is very much detailed in the elements of agriculture. He was interested in the land economy and the relationship between people, the land and the state. His hard labour on the farm is an experience that almost certainly shaped his later thinking about labour, hierarchy and the dignity of work. And the relationships that he talked about between the right amount of land and sea to influence the weather and the regional differences of soil, land and weather, and how that influenced crops and where they can be grown, is essentially the principle behind the modern land capability of agriculture classification and mapping system that we use at the James Hutton Institute. But again, there's no direct line of connection. We didn't study what Hutton studied and came up with this. We effectively reinvented the same understanding from his time. And I'm going to show you the maps of land capability for agriculture in Scotland. And the map on the left shows you the amount of prime agricultural land in green and yellow in the 1980s, 1990s. And the map on the right shows you what that might look like in the year 2050 if we have certain scenarios of climate change. Somewhat surprisingly, it shows that we potentially could have more prime agricultural land in the future because climate strains on temperature, on rainfall, for example, could be less. But it's going to be much more variable. It's not going to be easy to actually get good yields of crops from these lands when there's so much variation in rainfall and temperature. And there's some real challenges ahead for us on that. Hutton was a real fan of the soil, and you know the way we understand soil today in terms of its formation processes is dependent on the geology, the slope, the climate, plant types, the soil biota, and time. And the soils of Scotland are very diverse and relatively young, and they form slowly, but can be quickly degraded. Formation rates are typically less than a centimetre per century, and actively growing peat only about 0.8 millimetres per year, such that 2 metres of depth is about 2,000 years of growth. And the rates of loss are far, far greater than formation. So soil is essentially a non-renewable resource. Hutton really got to grips with soil and the elements of agriculture. Probably wrote as much about soil as any of the other subjects. And all of this was done at Slyhouse's farm, which you can see here today, still exists. And you can see the window that Hutton would have looked out onto his garden. And looking out, you can also see potato fields. And he was one of the first to observe potato growing in Scotland, in fact. And his work here at Slyhouses, I think, was incredibly important because I think this is the Scottish soil that helped change our view of the world. This is the soil profile at Slyhouses, showing how it's developed on old red sandstone. And what we know from all the studies the James Hutton Institute have done on our soils is that old red sandstone is prone to erosion. That was incredibly important in terms of Hutton's experience on the farm. He was trying to combat erosion, filling his ditches, and started to ponder how soil was formed and lost. He realised there had to be a renewal process taking place over longer periods of time. He also rightly surmised there was a connection between the parent rock material, the vegetation, and several of the soil forming factors, and therefore was really ahead of his time. Most soil scientists are taught that the Russian schools were the first to really identify the soil forming factors. Hutton was pretty far ahead. He didn't get everything right. He didn't underappreciate the soil biota, which is a bit ironic for me as a soil microbiologist, I have to say. But the James Hutton Institute do a huge amount on the soil biology these days. And that's because we understand that the health of the soil is very much dependent on the biology of the soils. And the big circle that's shown on this slide here is the deep sequencing of the national soil metagenome that we've undertaken. So we've extracted the DNA from the soil and we can map the genetic types of bacteria in the soil. And it's like an extended family tree that's been folded into a circle to make it fit on a page. But this is a huge topic these days and something that Hutton hadn't appreciated in his time. Similarly with crops, he was very interested in crops. He was interested in dye plants and elements of agriculture. He had chapters on barley and potatoes, in fact, one of the first to write about potatoes in Scotland. And he really understood how potatoes could revolutionise our food security. He understood the importance of seed and that plants will, no matter what hardship they face, still manage to produce a seed that can fulfill its potential the following year. And he also understood that the environment selects the fittest crop, effectively the principle of natural selection, 80 years before Charles Darwin. But very interestingly, he was in correspondence with Erasmus Darwin, who had very, very similar ideas. So again, illustrating how these individuals would speak to each other and share knowledge and information. So for today's modern day James Hutton Institute, crops are a really important subject. We've been breeding new varieties for over 100 years at the James Hutton Institute. But the problem is we don't have 100 years to breed new crops. We have to breed crops much faster in the future so that they are climate proof. And also they need to meet new farming approaches, especially regenerative low input systems, so that we can have much more resilient agricultural systems to the very variable climate that we're going to experience in the future. I'd like to think that James Hutton would be proud that our research on potatoes is also extended to sub-Saharan Africa, and we're doing some wonderful work there, I think, around introducing new heat-tolerant varieties that can extend the range of growing potatoes in Africa. They're disease-resistant, fast-cooking and early maturing. These are all traits that are highly desired by African growers and consumers. And the kind of impact we can have here is really quite large in terms of the number of people affected. And again, from my point of view, what's wonderful about this work is social science working together with crop scientists. Social scientists talking to communities, understanding what they really, really need, and then working with the crop scientists to make sure that we give them what is appropriate for their environment. So in terms of the modern James Hutton Institute and James Hutton, there are connections, but also potentially lessons. The depth and diversity of science has grown enormously, but we also embrace new ways of doing science, such as living labs and action-based research, and especially working in communities and connecting land and people. There's clearly strong links still in terms of applying the scientific method, systems thinking and evidence for understanding process. But what lessons do we take on board? For me, in terms of what Hutton talked about, the rigour and the care and the honesty about error and uncertainty and humility are really important things to take on board as lessons for the future. But also that solving problems is not incompatible with doing groundbreaking science. And also think quite controversially that science is not enough. Philosophical questions are needed, and collaboration of the arts and the humanities is essential if we're to solve the global challenges. And maybe a small lesson for some of our early career scientists is we often hear talk about people who should publish or perish. I would say tell your story well or it will get missed. Hutton didn't always tell his story well, and I think it has been missed. So we need to get out, we need to be seen and be heard. And I'm fortunate we've got some wonderful scientists who do that. They go to have pints of science and comedy clubs to talk about their work and get out and talk to people. And I think that's exactly in the spirit of the Enlightenment as well, is to get out where people are and talk about the science. I'm quite often asked, what would Hutton be doing today if he were alive? And I think he would be very motivated about the climate and nature crisis. We have a disrupted system that needs fixed. It's ripe for system thinking. Geologically, he might have been interested in geothermal energy. He had a very strong interest in heat and climate. But he might also have been interested in carbon dioxide removal and rock weathering, which brings in chemistry. There's no shortage of things for James Hutton, if he were alive today, to start doing work on. He might also have started to think about beyond the Earth. It's quite clear from John Clarke's Lost Drawings that Hutton and Clarke were thinking about the mountains on the moon. And, he maybe started to think about planetary geology as well going forward. So who knows what he would have done. He would have been very capable, I'm sure, of whatever he chose to do. So in terms of reflecting back, I think about this combination of arts, sciences, philosophy, and I wonder about if we could combine the insights of Hutton with the empathy of Burns would man's dominion have wreaked such damage on nature's social union? Hutton gave us a natural philosophy and a theory of systems that is in balance and is dynamic. He said we cannot be sure of the truth of our deductions without the constant application of experiment and the appeal to nature itself. He's pleading with us to think about the natural world, the natural balance, and the systems approach to be sure that we've got it right. That's much more philosophical than scientific. And we also need to understand it and place it in a context of a time that's much deeper than human existence. That's an incredibly difficult thing to do. As he said, time, which measures everything in our idea, is often deficient to our schemes, is to nature endless and has nothing. So, coming to some conclusions, I wonder what are the philosophical questions for the next 300 years, and I invite you to speculate on that. How do we align human timescales with Earth timescales? What is Scotland's duty to the deep future? Can society act on scientific knowledge before crisis forces it? 300 years is at least 10 generations. 300 years probably could restore our native pine woodlands if we were organised and had the resources to do so. 300 years might grow only 300 millimetres of restored peat. 300 years to mitigate climate change might be possible, but what climate would we get, and how could we ensure it was fair to all in the world? I do think such change and such thinking needs philosophy, arts, humanities, and science all working together in a true environment. So I'd like to make some acknowledgements next to my many colleagues in the Tercentenary campaign and at the James Hutton Institute, our funders and supporters. And on Hutton and Enlightenment, I've learned a huge amount from these individuals who, in various occasions, I've had conversations, listened to them speaking, read their work, and also including the writings of Jean Jones, who I would recommend anybody goes to find out about at James Hutton. If you would like to know more about the James Hutton Institute and what we do, you can take this QR code, and indeed you can join the Friends of Hutton at the organisation and get newsletters and information about what we do going forward. We'd love to have your support. Getting public support is incredibly important for us, and we're always looking for input and ideas on that. So I've reached the end of my talk. I hope it hasn't been too fast. I was trying to catch up on the lost time, so apologies for that. But I'm very, very happy to get questions, and hopefully I have left enough time for some questions, because I would love to know what your thoughts are.
Colin, thank you so much for that. Can we all have a virtual clapping? You took us on a wonderful tour of from the Enlightenment to today to the future, and you showed us what a big impact thinkers like Hutton and the Scottish Enlightenment, have not just in their own time, but they've persisted and stimulate us and give us ways of looking at the future. And I particularly liked your ideas on collaboration of arts and sciences, psychology, sociology, and so on. That this is actually exactly what the aim of the Leeds Literary and Philosophical, sorry, I should say Leeds Philosophical and Literary Society, that way around. Of course, philosophy in our naming of the society, which started just over 200 years ago, a little bit after the time that you were talking, stemmed very much from the Enlightenment and members of the communities in Leeds coming together to kind of look at these very important problems, and we think that we're doing that in the future. So I think there is much in our approaches, even though we're we're not a hard science organization, but I think the philosophy that's driving all of us is very interesting, actually. Thank you very much again, and I think I can speak for everybody here to wish you and the institute every success. I know that under your leadership, they'll go from strength to strength, and we're looking forward to seeing what you can do to improve not just Scotland but the rest of the world, maybe even Yorkshire, with your work. Thank you very much. Now we are taking questions on the Q&A here, and I think that I was going to be fed some questions to ask you. I should also say that on the Q&A, there's lots of congratulations coming into you, and lots of very warm words in the chat coming into you, Colin, for a terrific talk. So, Nadia, can you kind of offer me any help on this? I'm just having a look at the questions. Nadia, who's sort of masterminded a lot of this, in fact, probably all of this presentation. So as well as my vote of thanks to Colin, I'd like to make a vote of thanks to Nadia, who's organised, I think, just about everything here. And we also have our events secretary, Rachel Unsworth, at LPLS, who is on the line as well. So, we are so grateful to these folks for helping us. So, the question here is that maybe we'll just take the first consolidated question. Will global warming be evidenced in the planet's geology? What's the impact of warming on geology?
Oh gosh, right. I mean,
I know that's not your specialty. I think.
No, I'm not a geologist, and
No,
it's a very controversial subject when you start to talk about the Anthropocene with geologists. But I mean, clearly, there's in geological time, it's so vast compared with even the sort of formation of soils, which will be affected by climate change. So there is a big debate about whether you would ever see climate change effects in the geology of rocks. The time spans are so vastly different. But clearly we do see evidence of that. We've seen in topsoils, and we see evidence of past influence of man in topsoils, and but it's that time span is so vastly different. It's difficult to say that would happen in it. And it doesn't mean to say, there'll probably controversy, that we shouldn't recognise the Anthropocene age, because it's useful potentially to focus minds on how we are changing our planet. And we are changing our planet in terms of the Earth systems. But whether that would ever be reflected in the long-term geological record is a different question, I think.
Let's move to the second question. It's really about, I guess, in a way, scientific method, Hutton's scientific method, and our scientific methods of today. And I'll just read you the whole question. The skilled observation in the field of rocks and their context was key to James Hutton developing his theory of the Earth. Has this essential skill deteriorated in current scientific methodology, particularly with the advent of AI? AI maybe was a silent thing that was present that you didn't really touch on. It was on one of your slides, but you didn't touch on it too much.
Yeah, I mean, AI is clearly a massive change in science. We do use AI a great deal. Probably hundreds of different types of AI applications are used in the James Hutton Institute of various things. But you have to have very strong policy around how you use AI. And it is a tool which is very useful for speeding up science, particularly image analysis and lots of other ways of analysing data. but it's the intelligence you put into it that's really important, not the intelligence that's in there. And we see great opportunity using AI, but it has to be guided by the right questions. It has to be guided by the right inputs. And in fact, we see the revolution that AI is bringing, putting even greater emphasis on primary data. AI is nothing without good primary data. And I think the job of scientific institutions like us is to ensure that we have really solid evidence, solid primary data, to make sure that AI is using the best available data to help us all solve problems in the future. But I think for me, in terms of Hutton's approach, we're very faithful to the scientific method. But I think there's more than one way of doing it. And as I say, I think we maybe need to get a bit more philosophical about what we do. And we often don't do enough systems type approaches. We're very strong on the systems type approach in many ways, but people like to break things down into components to understand things. But then you have to rebuild them again. And it's a continuous cycle of going from systems down to looking at the individual components and rebuilding. And it's a continuous process, but we very often don't have enough people doing the systems side of it.
Yes, that's a good point. So we've got just a couple more questions, which are maybe a little bit lighter. Somebody's asked, what do you think Hutton would have thought about being so famous when he was 300 years old? Well, I can't think about how anybody would think the possibility of them being 300 years old, but have a stab at it.
I think in terms of what we know about him, he was quite unassuming and humble individual. Although he's very popular with friends, he was quite gregarious and very good company. So it's not like he was an isolationist, but at the same time, I'm not sure he certainly wouldn't be comfortable with social media these days, probably. I think, he very much was highly focused on what he was doing. Very singular focus on what he was doing. And there's a very strange period in his life where he effectively self-isolated on a farm in Slyhouses. And that was, after his son had been born. And, that's somebody who grew up in a city, with all those people for a very long period of time, almost 13, 14 years, almost self-isolated on a farm. I don't think he would have craved to be famous.
Yes. So I think the final question that I have is really about I guess really his life in a way, and we maybe kind of draw this to a bit of a close. Does James Hutton's example have any relevance for us today? I mean, this is interesting because, of course, a lot of science today is about patenting, big money. I think Hutton would have eschewed all of that, but how would you think about that?
Yeah, I think I think you have to remember that when Hutton first started applying science to problems, he was trying to solve those problems with science. He effectively was an entrepreneur at age 24 when the Salomoniac process was invented. He made money from that. It wasn't that he was only interested in high academic subjects. He was out to solve problems. Same with the Clyde, the Fourth Canal. He was very motivated to solve problems. So whether he would be comfortable with the way in which we do research in highly intellectually protected ways, I'm not sure, because that wouldn't have been a factor in his time. But he was very much about improvement and progress and solving problems. So he would have been an innovator today, probably, I'm sure. Whether he'd be interested in patents and commercialization, etc., I'm not quite sure. But having that financial independence is what allowed him to pursue higher things. And and I think it's interesting to reflect on that.
Yes, indeed. Well, thank you very much, Colin, for a most stimulating talk, and thoroughly enjoyable talk as well, and a really great evening. And I think we'll let you retire and have a wee nip of your single
I'm not
malt
sure I'm allowed to open it, to be honest.
from Aaron. Great. Well, thank you everybody for attending. We've still got more than 100 people with us at the moment. I think we were up to many more than that. And this is the largest webinar that I've ever been involved in. So well done to everybody, and well done to the James Hutton Institute. And I think we'll all be thinking about James Hutton in the future, and wishing you guys in Dundee and Aberdeen and Invergowrie all the very best.
Thank you very much for the opportunity. And thank you for people listening.